Hello. Welcome to physics. Today we are discussed about the electrostatics. Electrostatics is a most fundamental topic of physics and also most important for JEE and NEET exam. Here we are discussed about the basic concept related to electric field due to point charge, electric field due to group of charge and electric field due to distributed of charge, and related to JEE mains and NEET exam. And let us start one by one, step by step, each concept of the electrostatics and also electric field. Initially we are discussed about the electric field due to point charge. Mean electric field due to point charge, right? Suppose that this is a point charge q, and if I want to calculate electric field at point A, separation distance between A and B is r, then electric field at point A along this direction, because this is a positively charged, and electric field E equal to k times q divided by r square, and E equal to q divided by 4 pi epsilon naught r square, because k is a electrical constant and the value of k equal to 1 by 4 pi epsilon naught. Another value of k mean 9 into 10 power 9 Newton meter square per coulomb square. Here epsilon naught is a permittivity of free space, permittivity of free space, right? And its a value epsilon naught equal to 8.85, right? 8.85 into 10 power minus 12 coulomb square divided by Newton meter square. This is a basic logic about the electric field due to point charge. But suppose that electric field due to negatively point charge, as like this is a negatively point charge, and find the electric field at this point. Suppose that this is a point, then magnitude of electric field same, but direction inside. Here direction inside and here direction outside, because this is a positively charged and this is a negatively charged, and the value of electric field same, right? Mean q divided by 4 pi epsilon naught r square, right? This is a basic logic about the electric field due to point charge. And the graph electric field versus distance, because electric field and distance is a inversely square proportional, then graph as like this, right? Because electric field is a inversely square proportional to distance between both point. And suppose that electric field due to group of charge, electric field group of charge, right? Suppose that this is a charge q1 and this is a charge q2 and this is a charge q3, and similar this is a charge qn, right? And if I want to calculate resultant electric field at any certain point, suppose that resultant electric field at this point, and this is a origin, right? This is a y axis and this is a x axis. Electric field at this point, this is a origin 0 and 0, this distance r3 and this distance r1, and this is a r2, and this is a rn, right? And the resultant electric field at origin point. Now resultant electric field at origin due to q1, q2, q3 and Qn charge, and all point charge located at different locations and distance from the origin R1 and R2, R3 and Rn. Similar. Then electric field mean net electric field equal to E1 plus E2 plus plus En, right? E1 is a electric field due to Q1 charge and E2 due to Q2 charge, and similar En electric field due to Qn charge, mean number of charge, Qn charge, right? And put value here, E net equal to K is a common factor from the each step, and here Q1 divided by R1 square plus Q2 divided by R2 square plus plus Qn divided by Rn square. Similar for the next step, K mean electrical constant mean, and summation of all step mean Qi divided by Ri square, and value of I mean initial term from 1 to n, right? This is a basic concept about the electric field due to group of charge, right? And this formula valid only point charge. Note, electric field E equal to KQ divided by R square, mean Q divided by 4 pi epsilon naught R square. This formula valid only point charge, not valid, does not valid for distributed charge. Right? This is a basic criteria of this formula, mean electric field due to point charge, and most important concept for the JEE exam and also NEET exam, and some numerical problem related to JEE Mains exam and also NEET exam. First numerical problem, question 1. Suppose that this is a uniform charge rod, right, and positively charge distributed uniformly, and length of the rod L, and linear charge density lambda, and total distributed charge Q. Find electric field at this point. This is a O point and this is a separation distance R. Find net electric field at point O as given figure, right? Very simple solution for this numerical problem given for the JEE exam, and solve this problem step by step. Initially we cut a small strip. As like this. This is a small strip, right? And here dq charge, and this is a x separation distance, and thickness of this strip is dx, right? And electric field due to this small strip at this point, mean electric field due to plus dq charge at point O, right? Using the formula of Q divided by 4 pi epsilon tau square, because this is a valid only point charge, and this is a also work as a point charge because dq charge as like this, dq charge, and this is a separation distance, this is a point O, and this is a x, right? And this charge work as a point charge, and electric field dE equal to dq divided by 4 pi epsilon naught x square. And now using the value of dq, mean a small amount of charge, mean dq equal to lambda times dx, because lambda is a linear charge density, right? And this value put here, then value of electric field E equal to lambda times dx divided by 4 pi epsilon naught x square. And now total, mean resultant electric field 8.0, right? Mean integration both side, integration dE equal to integration lambda times dx divided by 4 pi epsilon naught x square, and using limit from r to r plus l, right? Because according to given situation, this is a r and this is a only l, and total distance from this end r plus l, right? And here equal to E, and lambda divided by 4 pi epsilon naught is a common factor, mean constant, and integrations x power minus 2 dx using limit r plus l, right? Using the formula of integrations, basic formula of integration, x power n dx equal to x power n plus 1 divided by n plus 1. Same concept using here, right? Then value of electric field lambda divided by 4 pi epsilon naught. Integrations using integration concept, mean x power minus 2 plus 1 divided by minus 2 plus 1, and using limit from r to r plus l, mean E equal to lambda divided by 4 pi epsilon naught, mean x power minus 1 divided by minus 1 from r to r plus l, limit upper limit and lower limit, mean E equal to minus lambda, this negative transfer here, mean lambda divided by 4 pi epsilon naught 1 by x, and using r plus r to r plus l. Now using finally limit upper limit and lower limit, lambda divided by 4 pi epsilon naught 1 by r plus l minus 1 by r, and E equal to lambda divided by 4 pi epsilon naught 1 by r bracket minus 1 by r plus l. Now solve further step, lambda divided by 4 pi epsilon naught r times r plus l, and r plus l minus r, and r plus minus cancel out to each other, and E equal to lambda l divided by 4 pi epsilon naught r, right, r plus l. And lambda l is a total distributed charge, right? Lambda l is a total distributed charge, and written as q divided by 4 pi epsilon naught r plus l, right? This is a basic explanations, basic numerical problem related to JEE exam, and most important result for your exam, and also concept. Let us start next numerical problem related to this. Suppose that this is a non-uniform electric field, right? This problem based on the uniform electric field, mean uniform charge distribution, and this problem based on a non-uniform charge distributions, right? Based on non-uniform charge distributions. non-uniform linear. Right, suppose that this is a linear charge distribution but non-uniform, and here charge distributed as like this. Lambda is a function of x and lambda equal to b times x, right, b times x, and b is a positive constant. B is a positive constant, right. Find electric field at this point. This is a point. Find electric field at point O, right. This is a separation distance r, and this separation distance is L. Similar numerical problem, but here some basic change. But initial problem, uniform charge distribution, uniform linear charge distribution, but in a second numerical problem, non-uniform charge distribution, mean lambda is a function of x and lambda continuous change with respect to displacement, right. Solve this problem, right. Initially we cut a small strip as like this, dx thickness, and this is a x. Now electric field due to a small charge dq at point A. Using the formula of electric field, mean dE equal to dq divided by 4 pi epsilon naught x square, and value of dq mean lambda x times dx, right, and dq equal to lambda x mean linear charge density b times x, mean bx dx, right, and this value put here. Then value of electric field mean net electric field dE equal to integration of bx dx divided by 4 pi epsilon naught x square. Here E equal to b divided by 4 pi epsilon naught, and integrations 1x cancel out to this, and x power minus 1 dx using limit from r to r plus L, right, and integration of x power minus 1 equal to ln x, mean E equal to b divided by 4 pi epsilon naught ln x, and using limit from r to r plus L, and net electric field finally b divided by 4 pi epsilon naught ln and r plus L divided by r. This is a basic logic related to electric field uniform and non-uniform distributions, right, and basic concept about this, basic logic about this, right.